Hello, here's our first video for section 2.4. It's called Gaussian Reduction. We'll learn what Gaussian Reduction is in a second, but actually mostly what this section is about is systems of linear equations where you have three equations like so instead of just two equations. Now, the method for solving these is going to be basically the same idea as before, but first we're going to look at a simple kind of system like this where you can use a method called back substitution. And what that is basically solving for one of the variables, here. In this case, first we can start by solving for z. And to do that, I'm going to take this orange equation here, 3z equals negative 3, and if you just divide both sides of that by 3, then that gives you z equals negative 3 divided by 3 is negative 1. And then you can back substitute, which means plug that into these other equations here, but replacing the z with negative 1, which makes it so they have fewer variables. And that's the problem right now, is the green equation has three variables, so you can't just find a number for x, for example, because you don't know what z and y are. But we can now use the second equation, this purple one, but I'm going to replace the z with negative 1. And that gives you an equation that only has y in it. And then you can solve that equation the normal way to find y as a number. So let's do that. First thing is negative 4 times negative 1 is just positive 4, so you get that. Let's subtract 4 from both sides. That gives you negative 2y equals negative 6. From there, you can divide both sides by negative 2, which gives you y equals 3. Then, if you know the value of y and you know the value of z, then if you plug them into the first green equation here, that will give you an equation where x is the only variable. And then you can just solve that equation the normal way to find x as a number. So that's going to look like this. So this equation now has x as the only variable. You can just solve it in the normal way to get the value of x that goes with this. 2 times 3 is 6, plus 3 times negative 1 is negative 3. So 6 minus 3 becomes positive 3. Then just subtract that 3 from both sides, and you get x is negative 1. So let's check that that's a solution of the system, and for it to be a solution of the system, it needs to work in all three equations. So our value of x, y, and z. So for the first equation, let's check it like so. Here's that first equation with all of our three values plugged in. We end up with negative 1 plus 6 minus 3 equals 2, and that is true. So at least that checks with the first equation. Let's try the second one. That gives you negative 2 times 3 is negative 6, plus 4 equals negative 2, and that is true. So it works with that equation. And then with the last one, all you need to do is plug in 3 times z. That would be 3 times negative 1 equals negative 3, and that is definitely true. So all three equations are true when you plug in x is negative 1, y is 3, and z is negative 1, so that is your solution. So now that you've seen one example of this, you should try it yourself using this back substitution method. Here is one for you to try. Same idea as before, just do it yourself this time.